So thank you for taking the time today to join us for our webinar where we will show how to bring in drone data inside of Cintoo Cloud. Just for your reference, this webinar will be recorded for future use. If you do have any questions, please type those in the Q&A panel and we will answer them at the end of the presentation. Today's agenda, we will talk briefly about Cintoo Cloud, followed by several examples of how to upload different types of drone data into Cintoo Cloud. We will follow that up with a question and answer session. Today's speakers will include myself, Rob Rasnick, Worldwide Sales Director of Cintoo, Nicholas Zarnick, who is our Customer Success Manager based on the West Coast, Joel Carlos Piero Fialho, who is our Customer Success Manager based in France, and Dominique Poulikin, our CEO and Product Manager, who is based in Miami. So now let's talk briefly about Cintoo Cloud. Cintoo Cloud is here to support your digital twin efforts. We consider a digital twin to be a realistic digital representation of your assets, processors, or systems in the built or natural environment. We break this down into two specific industries. The first one being Industry 4.0, which includes automotive, manufacturing, and oil and gas. The second one is what we call BIM, or AEC, for architecture, engineering, and construction. This allows you to run prototypes and what-if scenarios and simulations, as well as run predictive maintenance for all of your project needs. So now let's talk about Cintoo's core technology. With Cintoo Connect, we take the 3D point cloud either as an E57, RCP, RCS, or FLS file and convert that locally on your computer to a 3D mesh. By doing this, we reduce the size of the footprint of the data anywhere from 10 to 20 times. This is what allows us to view this mesh in a browser very easily and quickly. Also, we have the ability to do a reverse transformation where we can bring the data, the mesh data from inside of Cintoo back down to the local computer as an RCP or an E57 file to be used in your authoring software. Through this process, there is no loss of information between the precision or the accuracy of the data collected. This is truly unique to Cintoo and is very valuable as you can either download complete scans of an area or you can also crop a region and work specifically on area, which also saves you time in the data footprint of the RCP or point cloud file that you're working with. So the Cintoo Cloud platform is all about being able to collaborate, share, and distribute your scan data with others on the project team. People can be based anywhere in the world, and you will be able to share your data real-time on the cloud in a SaaS application. All of your data is hosted in either Amazon Web Services or Microsoft Azure. You select which location for each project. Additionally, we are also SOC 2 Type 2 certified, which is one of the highest levels of certification that can be achieved and assures you that your project data is secure. So now let's talk about the Cintoo Cloud ecosystem. Currently, you will go out and scan the project using your hardware device of choice. You will then register that data using your software of choice, which typically comes with the hardware. Once you do that, you will run Cintoo Connect, which runs locally on your computer and converts that point cloud to that mesh format, which is then pushed up into your project inside of Cintoo Cloud. Once inside of Cintoo Cloud, everything is mesh-based. You also have the ability inside of Cintoo Cloud to create reports, create issues, measurements, annotations, and it also comes with a shared viewer, which allows you to share a hyperlink to the project for other project members to view. We can also bring the data from a mesh back down to a point cloud or a mesh to use locally on your machine for your design practices. We also have a connection to Autodesk Construction Cloud to bring in model data and also push out issues. And we can also connect to BIMTrack and Procore to create issues as well. So once again, Cintoo Cloud is here to serve the digital twin industries. Industry 4.0 again is for the automotive, manufacturing, and oil and gas spaces. and BIM addresses all those AEC processes for architecture, engineering, and construction. So Cintoo Cloud has basically three main value propositions. The one is around it's a reality data platform, meaning that you can collaborate, share, and view this point cloud data as a mesh, which makes it much easier to use. And it's really here to democratize the use of point cloud data in the industry. The second one is around visual analysis for quality control and quality assurance. This allows you to compare your BIM model to your as-built data to make sure that everything was built as designed. If not, you can create issues and alleviate the headaches that come further downstream when you realize that it's too late to fix these. The last one is going to be newly introduced is around asset management. The idea here is to create asset tags inside of Cintoo, which then will connect to your digital twin platforms. This is a great way to save steps and to start your digital twin journey, as you do not need to model the elements. You can simply go in, create a box around that asset, and tag it with all sorts of metadata. More to come on this in the very near future. Currently, there are over 400 companies in 43 countries using Cintoo Cloud. This equates to 3.5 million scans uploaded with over 20,000 models and 45,000 users. So with this, I would like to turn it over to Dominique Pouliquin, who will discuss the different ways that we can upload drone data into Cintoo Cloud.
Thanks, Rob, for this introduction. So before going to the drone data, let me step back and tell you where we stand in terms of having a hardware agnostic and multimodal platform. As you know, reality capture is not limited to one technology or one device. And there is not one device that fits all the use cases. This is why we have been able to upload terrestrial scans for about a few years now. And that also includes a new Matterport Pro 3, which is a very much similar technology. We are also now being able to upload more indoor mobile scanners, scan data coming from Navis, VLX, M6, Leica, BLK2Go, Geoslam devices or via Metris, or any other one through a generic E57 that will contain your camera trajectory. All the same, you can use the same technology for MSN overmap, which is a LiDAR on the drone. The same LiDAR device can also be handheld. Very cool device. Also the same technology to upload your smartphone data if you have. And also for for 360 panels, we can upload aligned 360 panels. We don't do the SLAM piece, but once you have aligned 360 panels, you can upload that as well to Cintoo. And now let's talk about drone data. So the way it works to upload drone data is the following. Again, we don't do the stitching. The stitching of your photos will be done using your traditional stitching platform like Drone Deploy, Pix4D, or Recap Pro. And from those platforms, you'll get various data, including a point cloud. Now, this is the one we will be using for Cintoo. Okay, today we upload a point cloud in E57 format. And if you have only LAS data, it's very easy to convert LAS to E57. In our documentation, we do provide two easy ways to convert your LAS files into E57 before we support LAS as well, which will come in the next few months. So either you use Recap or you use a Cloud Compare to turn your LAS files into E57. So you end up with a E57 point cloud. And globally, how does it work? Okay, what we will do, we will use this point cloud, which is unstructured data, and we will convert it to a structured data, as if the data would have been captured by a flying static scanner. Okay, and then you can experience your drone data inside Cintoo Cloud the same exact way you would experience your terrestrial scans. That includes, of course, going scan to scan, and you see the quality of the panoramic images that we did create here. All those panoramic images were created from the point cloud only. We didn't have access to the source photos. And then you can really navigate your drone data as if you would be in a Google Street View type of experience, which we know is a preferred experience for non-experts. This is why we do that. We want to really democratize access to the data. And then you can use various shaders we have with the 3D mesh. You see the quality of the mesh we have produced from this point cloud. Like, for example, this is a height map. Going back to the 3D, to the 2D panoramic image here, going to the next vantage points. Those vantage points, we'll call them virtual vantage points. It looks very similar to what you get from a static scanner again. Of course, you are not limited to scan mode. You can also navigate in 3D navigation mode. And we're very happy to introduce a new version of our acclaimed Turbo Mesh rendering engine. Turbo Mesh engine is a very fast rendering engine running in your WebGL browser that will aggregate various meshes from various scans participating to the field of view in real time to display the best mesh with the highest resolution possible, so that you don't see any difference between your scan mode and your 3D navigation mode. So we are really introducing a new paradigms here in navigating your drone data in a very similar way that you would navigate your indoor scan coming from static or mobile scanner. So going into more detail, how does it work? The overall process is the following. We start from the raw point cloud, which is called an unstructured point cloud. Then we have algorithms that will sample the space with virtual vantage points. And for each one of those virtual vantage points, we will take into account only the visible points from this position. This is where we recreate structured point cloud. Okay. And from this structured point cloud, we apply the same Cintoo core technology, which is a point cloud to mesh, to create this compressed multi-resolution mesh for each position as for static or mobile scanner. And this is where you get your Cintoo Cloud mesh-based scan data. And of course, this is all automatic. The user has nothing to do to get that. Going to a little more detail, why do we do that? Because this process will keep the precision of the source point cloud first. This is very important to know. There is no compromise. There is no decimation, no compromise on accuracy with Cintoo Cloud overall. It will generate panoramic using the point cloud color, as you could see, and that will make your scan data much easier to navigate. Again, that will be the Google Street View of your drone data. It will make it also much easier to merge various data types in a unique base viewing experience. Of course, can be scan to scan or full 3D navigation. And last but not least, you can turn this unstructured point cloud, or unstructured data, I should say, into structured or unstructured data that can be then exported in E57 or RCP format. You can also export it as a mesh in FBX, OBJ, or STL format. So again, going a little deeper into this explanation, let me tell you how we do sample to restructure this point cloud data. First, the type of flights that we support today are uniquely only this, what we call horizontal flights. We don't support vertical flights where you will fly your drone around a building or around our rigs, but this will come later. You can trust that we're working on that. And we also expect that you fly your drone and you create a point cloud that have a good enough point cloud density. Otherwise, our meshing technology will not apply. Okay, so we expect to have at least 1 point every 2.5 inches, basically. Then what we do? The only information that the user needs to give is the distance between each virtual vantage point. Then the process is all automatic. We will set the altitude of the vantage points automatically, taking into account the global point cloud density. Usually it's an altitude between 15 and 50 meters. These VVPs will follow the point cloud topology. So for example, you may have a case where you have vantage points above a parking lot and other vantage points above the building. So there will be always the same altitude from the parking lot or from the rooftop. And the resolution then of each VVP will vary based on local point cloud density. So we do a pretty clever job. Again, this is all automatic to turn that into very interesting virtual vantage points that you can navigate. Now, if you have to deal with linear infrastructure like highways, railways, and things like that, if we do apply the same sampling technique, this will not work because we may miss the information. So what we do here, we use other techniques like dart throwing on some other technology like that to make sure that the virtual vantage points we do create will cover the entire space regularly with the best possible resolution. One trick though, if you have linear infrastructure that is longer than 10 kilometers or 6 miles, we do recommend that you chunk the point cloud into smaller pieces, and then you upload each chunk separately. And you can use, of course, Cintoo Cloud work zones with uploading one chunk into one work zone to facilitate your navigation. So now I will leave it to Nick that will tell you how we can, how we do this upload using Cintoo Cloud and Cintoo Connect. Nick?
Hey, Dominic. Yeah, so I'll go through this process starting in the Cintoo Data tab. You can either select Upload Drone from the drop-down list, or you can select the Prepare and Upload button, and this will launch Cintoo Connect, which will process the data. So in Cintoo Connect, you can hit the Drone tab and select the E57 point cloud that you use as the import file. And Cintoo Connect will read that point cloud file and display the total number of points that are contained in the E57. And then the distance parameter will determine how many vantage points to generate and the estimated import time. So you can reduce the distance to generate more vantage points, which will affect the overall import time. Or you can also increase the distance value, which will result in fewer virtual vantage points to generate. So once you have the desired distance parameter set, it's a fairly automatic process, and all you have to do is just click the import button, and Cintoo Connect will handle the import and upload. So yeah, fairly straightforward. With that, I'll pass it back to you, Dominic.
Yes, thank you very much, Nick. So talking about processing times, this is what we have experienced. Like if you have to process like 2.5 acres, which is about 1 hectare, it will probably generate 6 VVPs. It will take about 30 minutes. Now, if you have more, of course, you see the numbers here. Make sure that we have an objective in the company to reduce this processing time. And in the next few months, probably we'll be able to divide this time by at least 5 or maybe hopefully 10 times. But this is what you will experience with this first version of the upload. Now, of course, the advantage of doing this is that you can navigate your drone data with laser scans. So let me show you an example here. I'm using here a dataset from our good friends at Worley. Worley is a global engineering firm with very active in chemicals, power, and mining industries. Please note that they also use Cintoo Cloud with our custom branding option. So here you have seen the drone data that was captured by Worley team in Aberdeen in the UK. You see you can navigate to scan mode, again, see the quality of the panoramic image that was generated from the point cloud only, navigating to the next vantage point. You can, of course, turn that to the 3D mesh. You see the mesh quality we have here for this data. Very beautiful mesh. Of course, going to full 3D navigation with the Turbo Mesh engine activated, you will see that you navigate in full 3D anywhere you want with the same mesh resolution that you have for each scan. This is very unique rendering engine. that we have in Cintoo Cloud. Also work with the color, of course. And navigate anywhere you want. We have various camera modes as well here. And let me now add some other scans. You see the beauty of the mesh, even in full 3D navigation. And let me now add the outdoor scans, okay, 71 scans that have been captured all around the building. So this is a typical terrestrial scans. Those scans have been captured without any color. That was a choice of the surveyor to save time, probably. So if you go to the panoramic image, you'd see that you have only the intensity here, no color. And you see the quality of the mesh that was produced by this static scanner. And as I said here earlier, the goal here is to provide the same exact navigation experience between all kinds of reality capture modalities, being drone or static scans. So really a good example of merging scan data from various sources, being drone or let me add now the indoor scans of this very beautiful building in Aberdeen. A very typical project. Again, there is no color here, so we navigate mostly in surface mode. Going into full 3D navigation, here there is a lot of scans that will contribute to this space, so it takes a little more time for rendering, but still, you have a very good experience. So this is what we do, merging drone data with static scans. And you may wonder now, how do we align drone data with laser scans, okay? Typically, in most cases, I should say, people will use the same survey points when they do the stitching using Drone Deploy or Pix4D, or also when they register the scan using Leica Cyclone or Trimble RealWorks or Faroscene. This is what people would do in most cases. But still, if you don't have this aligned data sets, what we can do is use a Cintoo Cloud capability. Again, on the same data set, we have a tool called the manual alignment tool to do that. And the way we recommend using it is first going to the X-ray display shader that will give you this kind of view. You can then go to any one of these views here. On switching to orthographic view will be the way to go. And then you see the contribution of this drone data here to the project. So once you have got your orthographic camera on one camera angle like this one, side view, you can go to the manual alignment tool, select, I want to align my drone data to my outdoor data, or you can do the other way around. So you have to select which one should remain at its position and which one should be aligned. And then you have various translation or rotation tools. So you can see that playing on the Z-axis, for example, I can easily move the drone data, which is a one to align, so that you can align, you can set it where you want. And if you zoom in, you can, here I'm using the mouse wheel, to move the data set, but you can also type any value, or also when you use a mouse wheel, you can use Control, Alt, or Shift to have a smaller increments. So when you get closer to where you want to go, what you do, you will press Alt, and then you will press Shift, and you will zoom in to make sure that the two data sets are being aligned. So Shift plus mouse wheel here will give you a very good sense. So then you can use a top view, for example, again, playing on the X or Y axis will translate your data set. And again, the drone data set is being moved here because this is a one to align. You can also rotate. You can also pick a pivot point. For example, here, I would use the top of this building as a pivot point. So every rotation now will be done around this pivot point. Be sure that you don't click on apply until you are sure of your alignment process. So everything I'm doing now will not be saved until I click on align. And I will certainly not do this because this dataset was very well aligned using survey points. So I'm just showing the capability here. But you will use the align button only when you are happy with your alignment. On today, there is no way back. So this is something we're working on as well, be able to come back to the initial alignment. So be sure you use it carefully. So here, just aligning the X and Y again. You can zoom in, adjust your two data sets very easily. Using the mouse wheel and Alt and Shift to get smaller increments. So this is a way you would align your data set to between your scan and your static or mobile scanner, between your drone data on your other scan devices. Another use case of why would you append your static scanner or mobile scanner with drone data, of course, is to get the rooftops and everything like that. And one of the reasons why is you would do that is to tag your equipment on the rooftop. So I will leave it now to Joao that will explain how to do what we get from that process. Joao?
Yes. Hello, everybody. So I will show you how we have used this mobile rooftop drone capture to tag some equipments. So here we'll start entering the data by using the overview map, going to X-ray mode just to locate ourselves and click on one of the virtual vantage points to enter the data. And as you can see on this rooftop, there is a lot of technical networks and equipments. So the idea is to be able to tag some of these equipments using the coming ATD module, asset tagging and display. So we create a list, and we are able to navigate from one tag to another, just clicking on the list or clicking on the mesh, which is highlighted here in yellow. So you can now identify and directly zoom into the tag position. On top of that, we can also have properties displayed for this tag. So here you see we have added some metadata. We can go to up to 20, but we have brand, model type, power, fluid. But you can also have links. So here in this case, we have a link to documentation. Here it is installation and operating and maintenance manual. But you can have links to your digital twin or maintenance tool or ERP. So jumping directly from Cintoo to this, and to do the round trip from your digital twin platform or other tool, we can create a link to the tag directly in Cintoo. So you will be able to connect. So here I'm copying the link with the tag, and it's opening directly the platform on the tag position. So this asset tagging and display module will be available in the next weeks, and you can also embed this Cintoo view into as an iframe into your digital twin. So these are just a quick overview of what you can do, and we'll have some news in the coming weeks to show you.
Yes, thank you, Joao. Again, asset tagging on display is a new module that we've been working on for months that will be released in the next few weeks. So be ready. And also we'll have a webinar, specific webinar on asset tagging on display to show you the whole process, how you can either manually tag from a CAD model like a Navisworks model, or tag from our AI engine also that will automatically geolocate and classify your equipment in the scan data. And this will be all available in a few weeks, so be ready. Last piece of demo, because before we move to the Q&A session, is to see how we can export this drone data, either as a structured and unstructured point cloud or as a 3D mesh. So what we have here again is the same data set from our good friends at Altarea or Cap Tramiel, which is a shopping center in south of France. Again, what's the first one will be to export a structured point cloud. So what you can do is select all your vantage points that were created, called virtual vantage points. Make sure that you get rid of all the files that are not vantage points. And then you simply click download, export scans, and that will trigger the start of Cintoo Connect. The same one, Cintoo Connect, that you use for uploading will be used to download and restructure and get your point cloud format. So you can select structure or unstructured. Here I select unstructured. You have various formats, including POD or CP. POD is a point tool format from Bentley. And you can select the decimation. So let's go for 1 point every 10 millimeter here. You just select the name on the folder, and then you simply click on export. It's as simple as that. And then you can, it would take probably maybe 30 minutes, 1 hour here, given the fact that there are about 90 scans to process. You can check on the messages where the process is. And at some point, you get a notification that it is ready, and you will see this notification in your Cintoo Cloud, Cintoo Connect, sorry. And you can see you go directly to your the folder that you selected to look at your point cloud data. In which case here, I selected recap as a format. So I use recap. I open directly the RCP file inside recap, and this is the point cloud that was generated from the vantage points I selected in Cintoo Cloud. Pretty easy. In this case, the point cloud is about 15 gigabytes, pretty heavy. This is one way to go. Another way to go is to export this data as mesh pieces. What you do first, you have to select the area of interest. You use a crop tool to do that. Cintoo crop tool can be used either with the XYZ sliders, or you can also click on the faces of the cube inside the 3D view. To get the opposite face, you have to press Shift, and then you use your mouse wheel. Very easy, very standard one. You can also mix the two, of course. You can also rotate your box here inside the 3D view by clicking on the edges. So you just select very quickly your area of interest, and you save it. And then there are two ways to export that. Either as a point cloud, you click on export, that will trigger Cintoo Connect again, or you click on mesh, and you select the mesh density, you select the mesh format being FBX or BJ or STL, and you simply press create. That will start the process in the cloud of unification, taking into account the best mesh contribution to generate this unique mesh. And at some point, you will be notified that you have to download this mesh from your data tab. And here, this is a result of this. This is the FBX mesh using a simple FBX viewer. And you see, you get a mesh that you can use. And of course, this mesh is geolocated, okay? You can have, if you add on this mesh is about 67 megabytes. If you crop another area that is adjacent to this one, and you put the two together, they will remain adjacent. So the geolocation is preserved when generating those meshes. Basically, this is what we had to show today. Happy to take a few questions if there is any. Rob, are there any questions for us?
Yeah, we have several questions here. So one of them you already answered, I believe. They're asking about how to align your drone data to your site or to your scan data, which you did a great job explaining that. Another question is do we support vertical flights?
So as I said, not at this stage, but this is coming, okay? We are working hard on this. We know this is a very frequent use case for drone data. So it will come, but this first version will process only horizontal flights.
All right, and another question is why can't we import point clouds from the drone with less than 200 points per square meter?
Because if you have a lower point cloud density, our mesh engine will give you some result, but will not be optimized. Our mesh engine, the same point cloud to mesh engine that's being used for static scanner, mobile scanner, or drone data, will take some assumption in terms of mesh, or in terms of point cloud resolution. So we have to be above that. Otherwise, they will give you a poor mesh quality.
All right, and another one is, how many structured scans or images can Cintoo support for drone data?
Or as many as you want. So there is no limit in the number of scans. As you know, the scalability is one of the key, aspect of Cintoo Cloud. We have customers that have project of 10,000 scans in one project. Usually they split that into various work zones so that they don't need to display 10,000 scans at a given time. All the same, with drone data, there is no limit. The limit will be more on the time it takes to process that. Okay, as you see, as you saw in one of the slides, it may take a few hours to process several hundreds of vantage points. So I would recommend, if you have hundreds and hundreds of vantage points, to wait for the new version that is coming that will be optimized for processing. But besides the processing time, there is no limit.
Okay. Another one, can Cintoo handle large area data from aerial sensors, like manned aircraft, or is it more tailored just for small areas?
I would say, yeah, I would not recommend, to be honest, I would not recommend using Cintoo Cloud for a big geospatial data set like city scale or big scale. There are other platforms that do a very good job for that. So this is more for buildings, campuses, rigs, refineries. So I would say sites that are, one building or a few buildings. This is where you will find the value of this technology.
Okay, and then another one is, how do we price this, the VVPs?
Yeah, good question. So, our pricing model is very simple, and this is part of the success, of course, of Cintoo Cloud, plus the fact that we have unlimited users policy. So please invite as many users as you want. Use Cintoo Cloud as much as you can. You just pay for how many scan data you upload, okay? So what we do create with those virtual vantage points, VVPs, is basically one VVP equals one scan. So we do monetize the same way. On the same way, I would say we use the same monetization for when you upload your unstructured point cloud coming from indoor mobile scanner like Navis VLX, for example. At some point, we restructure this unstructured data, so we recreate virtual vantage points all the same, so they can navigate your point cloud or unstructured point cloud as if it would be coming from a static scanner. So at the end of the day, you end up having a set of VVPs, which equals a set of scans. So we do monetize on how many VVPs you do create.
Great. I think that's all we got. So everyone, thanks again for your time today. If you have any further questions, please feel free to contact us. You can contact us at sales@cintoo.com or support@cintoo.com, and we'll get back with you as soon as possible. Thanks again for your time.